Hi, welcome back to example 2 for 7.1 simple interest. In this example, we're going to develop a linear model for simple interest. So it says Robert deposits 500 into a guaranteed investment certificate. This is called the GIC, and it earns 6% per year simple interest. Develop a linear model to relate the amount to time. So this is the total amount in the account. So it's going to be the principal plus the interest. It says identify the fixed part and the variable part, and then graph the function. All right, so here we go. Um, we want to develop a linear model for this. So we can say the amount varies partially with time. Okay, so the reason why we say partially is because there's a fixed part. So we'll say the fixed part is the principal. Okay, the fixed part is the principal, and that is $500. Okay, the variable part is the interest. Okay, the interest which is calculated, or we can say which is found by using I equals PRT. So what we mean by all this is the amount varies partially with time. So the amount is equal to the principal plus the interest. Okay? The principal is fixed, the amount that's invested, but then the interest grows with time. And when I say grows with time, it actually grows the same amount every year, year after year, as long as it's in the account. So it has a nice linear growth rate. So we can substitute the equation in for interest, and we can write this as P plus PRT. So that's one way to look at this model. All right, so we now want to graph this function. So I'm going to plug in some values in here. The principal was 500, and the rate is 6% per year. So we have 500 for the principal, and the rate was 6%, which is pretty good for a GIC. As a decimal, we write 0.06. So write 0.06 and then T. So you could see how this looks like a nice linear equation, right? We're going to write 500. We're just going to clean it up. 500 times 0.06. That's going to work out to 30. So this is my linear equation. So that part is actually the y-intercept. Okay, which kind of makes sense. It's the principal. It's the initial amount, right? Okay, the initial amount, also known as the principal. And then the other part is the slope. Okay, this is the simple interest earned each year. Okay, the simple interest is a constant amount. Okay, so it's gonna basically make $30 per year every year. So graphing this now becomes quite easy. We'll have our amount in the account, and we'll have time, which is in years. Okay, so we'll do about we can do about 4 years. So at time 0, we have 500. So I'm going to map out about 500 right here. And then I'm going to do 600 up here. So then we got 550, 575, 525. Okay, so at time 0, we'll graph this in red. We have the principal that's been invested. Okay, after 1 year, it's going to make $30, and I can tell because that's the slope of this. So remember, you can always kind of compare this to y equals mx plus b, right? This is just kind of written the other way. If you switch those terms, so there's our linear part, and then we have our y-intercept. So the slope is 30, meaning I'm going to make $30 each year. So plug in 1, I'd be at 530. That'll be right there. After 2 years, it makes $60, so there'll be another 30 in the count, so it'll be at 560. And then after 3 years, that's a total of $90 interest, so it'll be at 590. 590 would probably be about right up there. And then at 4 years, it'd be 120. We'd actually be all the way up at like 620, which would be about right there. So this makes a nice linear relationship. Okay, we can say the amount. If I write it as an equation, I would write 30t plus 500. Looks like my linear equation. So that's how simple interest works. It's one of the downsides to simple interest if you're investing. You only make that fixed amount every year. So you can see how this kind of looks like a staircase. Every time we go over 1, so for every 1 year, we only go up 30. So that's the slope. So you're only making $30 every year. So the thing with the GICs is that that investment is guaranteed to get that. That's why some people like to go for those. So if they don't really want to risk anything, maybe they're too close to a retirement or whatnot. So they choose a GIC. All right, for part B, it says how long will it take to the nearest month for the investment to double? So I'm just going to do this in green. So they want to know when the amount in the account is going to equal 2 times 500 because it needs to double. So they want to know when is it going to be 1,000. So the rate is still that 0.06%. That's at a decimal, 6%, so 0.06. And the principal is still 500. And now we're looking for time, right? The question said how long will it take? We want to find time. So I'm going to use this equation right here that we found. Okay, I could also use this here, right? Because I kind of identified all my variables that I could plug them in here. That's something I would normally do when doing questions like this, except we've already done a lot of groundwork for calculating the amount in the account. So we'll just set A to 1,000 and we'll calculate for T. So I'll call this equation 1 and I'll say sub A equals 1,000 into 1 and solve for T. So we have 1,000 equals 500 plus 30 times T. So we got to subtract 500 from both sides, giving us 500 equals 30T. And now divide both sides by 30. So therefore T is equal to, works out to about 16 2/3. that says a whole number. So it would be that many years. So a little bit over 16 years. So the reason why I wrote it as 2/3 is that might help you determine the month. So 2/3 of a year, you multiply 12 by 2/3, and then you get 2 times 4, so about 8 months in. So we could say, or 16 years and 8 months. So that's the only nice thing about leaving that as a fraction, right? So that's not a lot of time to double an investment. I mean, it's not the fastest, but it's guaranteed and it's not too bad. Last question. What annual interest rate must be earned so that the investment doubles in 8 years? So this is a little bit more ideal for the doubling period. So we're just going to add a little bit of space here. So for part C, it says what annual rate of interest must be earned so that the investment doubles in 8 years. So we're looking for R, right? What annual rate of interest must be earned? So the principal is still 500, and the time is 8 years, and we want the amount to double, so we want there to be 1,000. So you could also say, instead of saying A equals 1,000, you could say, or I want the interest to be 500, because that would double your money. If you put in 500 and your interest is 500, you just doubled the amount. So if I said A was 1,000, I would write A equals P. So the principal plus the interest. So I would say A equals P plus PRT. So we're going to have 1,000. The principal is 500. We're looking for the rate, and the time is 8 years. So we have 1,000 equals 500 plus 8 times 500 is going to be 4,000 R. Okay, I can divide both sides by 500. So I subtract 500 from both sides. So we have 500 equals 4,000 times R. Divide both sides by 4,000. And we get R equal to 0.125. So as a decimal, I'd like to say that's 12.5%. So the rate needs to be 12.5% or higher to double within 8 years. All right, so that's it for the second example. We have one more left, so I'll see you in the next video.